My name is Dan Good. I'm going to be talking about sculpture a little bit. And I guess I can tell you who I am before I get started. I'm a sculptor and engineer. A long time ago, I was an electrical engineer. I spent a lot of time in a bunny suit dipping wafers in acid and putting them in high temperature furnaces. Eventually, I wanted to get involved with more creative stuff. I did some electronic music. I wrote a lot of Max MSP patches, and eventually I wanted to combine the creative and the building things, and I ended up building a bunch of sculpture. So that's who I am. This is a talk about a design problem that I had where I wanted to build this sculpture. So here we go. I drew this in CAD. I built a bunch of metal sculpture in the past, but I had no idea how I was going to build it. And the reason it's hard is because it has these different parts that are overlapping in a complex way. They're not orthogonal to one another. They're smashed together, and it's just not very clear how I'm going to do it. I wanted the lines on this piece to be very clean. So I wanted you to be able to go right up to it and look at it and not see any sort of messy welding or anything like that. I wanted it to be very nice and inviting. I also wanted it to be strong. I wanted to be able to put it on display at a sculpture park or somewhere permanent and not worry about it collapsing and killing a child. And finally, I wanted the technique to be adaptable. I didn't just want to spend all the time figuring out how I was going to build this piece. I wanted to build a whole bunch of pieces, and I didn't want the creative part to be limited by the technique. So I didn't want, for instance, two pieces to not be able to go so close together or be limited on an angle or something like that. I just wanted to be able to draw stuff in CAD and know that I'd be able to build it. So before I talk too much about my process, I wanted to show you some sculpture that I like and that sort of influenced my thoughts about it. When you're a metal sculptor, the sort of two major processes that you might consider, just grand speaking, are casting and fabrication. Cast sculpture, so this is an example on the left. It's by Marty Eichinger, who's a local Portland artist. It's high detail, usually made of bronze, but the sculptor can work in whatever material they like. They could sculpt in clay or wax or wood. They could draw on the computer and 3D print it. There's all kinds of things they could do. And they take it to a foundry. They pay the foundry a bunch of money, and comes back their sculpture. On the right is a picture of the piece that's right outside here at PNCA. It's by Lee Kelly, who's also local to Portland. This is a fabricated sculpture. So to make this kind of work, you buy raw material, sheets or slabs or bars or whatever. You cut it up and you assemble. So you typically do a fair bit of welding. These two kinds of works are pretty different in character to begin with. You get a lot of detail in casting, and fabrication is pretty good for blocky things. So fabrication is naturally what I would have thought, but it's not necessarily. There's no reason I have to do it that way. Here are some examples of cast sculptures that I'm a really big fan of. On the left is a piece by Anthony Gormley that's made of cast iron. I think he might be my favorite sculptor of all time. He's really great. On the right is a piece by Joel Shapiro that's cast bronze. I totally could have done this for my work. It would have been very expensive. And actually, it turns out that just making the mold to make the casting out of for my piece, since it's so complicated, doesn't really make a lot of sense. I would have had to do some kind of complicated CNC milling or 3D print the whole thing. The piece that I'm trying to make, incidentally, is going to be about 5 feet tall. So 3D printing the whole thing would have been pretty challenging. As an example of some fun fabricated work, on the left is a piece by Julian Voss-Andre. He's also a Portland local. Julian makes these pieces by, he gets a model to sit for a digital scan, and then in software he takes the scan and cuts it up into cross sections. And in the cross sections he plans out little pinholes where the pins are going to go. You can kind of see them in the piece. Then has all the cross sections laser cut, and one by one puts them together with the pins until he gets the final piece. You can get a lot of detail with this technique. It's pretty cool. On the right is a piece that is done by an old friend of mine, Michael Walsh. And this involved no digital planning whatsoever. He builds a skeleton out of tubing, where he bends and welds the tubing together into the shape he wants and then skins it with thin metal. So there's a lot of different possibilities with fabrication. And it's a lot more accessible of a technique. Really, all it takes is a welder and some cutting tools. Yeah. So this seemed like a pretty appropriate technique for me, but I still had some things to figure out. I also want to talk about welding for just a second because you might not be familiar with it, but I know you're familiar with soldering. So I use TIG welding for all of my work, and TIG welding is actually pretty similar to soldering. The qualitative difference between TIG welding and soldering is that TIG welding, the base metal melts. So when you solder wires together, the wires don't melt. The solder is engineered to melt at a lower temperature than the wires. But when you're welding, everything melts all at once. You have to be careful to not blow a hole in your piece if you melt for too long and the weld falls out. When you're TIG welding, the most important piece is this tungsten wire here coming out of the torch. The torch is held in one hand and filler metal in the other hand, just like soldering. The tungsten wire comes out of the torch and conducts an arc to your metal plate. Typically, the amount of power that's moving, or current, there's about 50 to 200 or more amps coming out of this thing. It can move quite a bit of power really fast. You make a metal puddle, you fill it with metal from a filler rod, and then you take another step. So you end up with this stepwise textured process. When you're doing fabricated work, so this is not a sculpture, this is an engineering part, but you typically end up with sort of these two kinds of welds. You end up with outside corner welds on outside corners and fillet welds on inside corners. When you're doing a process like this, you can think of it as a pretty simple sort of fabrication plan. You draw what you're going to make, you cut it up into parts, you weld the parts together, and then you grind the parts to make it look nice if that's what you're concerned with. For an engineering part like this, there's no reason to do any finish work like that. But for my sculpture, this is the one that's upstairs, maybe you saw it, I want to do a lot of work to make it look nice. So on outside corner welds, like this one here, it's pretty easy to take a grinder to it and clean it up, make it look nice like these here. For a fillet weld, an inside corner here is actually much more challenging. You have to kind of get in there with your grinder and carve it out. And it's really tough to do well. It takes a lot of work, and probably you'll end up scratching up your piece and making a mess anyway. So this is the sort of situation that I was confronted with when I started working. So here's my initial drawing. This is the CAD drawing that I made that I stared at for a long time and said, what am I going to do with this? So the first thought I had is, well, maybe I'll just go for it. At the very least, I'll learn something. So the way I did it was I took every face that you see here, I extracted them out of the CAD, and I had them made. So it's a lot of faces. I got back a big pile of metal. I spent a long time sorting and counting and making sure I built the boxes correctly, and then I started putting them together. It actually worked surprisingly well. I'm sorry to show you a crappy old cell phone photo, but this is the sort of digital record I get from when I'm working in the shop. So the way I did this was I assembled each of the 6 boxes, I cleaned them up, and then I started attaching them together. I realized exactly what I was just describing to you before, this idea that making these fillet welds was going to be really challenging. So like in here in the middle, it was going to be really tough to get my welding torch in there, and if I could, it was going to be really tough to clean up the weld. So what I did for this one was I just put in little teeny tiny tack welds in sort of cleverly picked places so that I could get the whole thing to stick together. So I was really excited that I got my sculpture together. For a prototype, for a first try, this was really great, but there was no way that I was ever going to be able to show something like this. It doesn't really look very good. You can see the construction process on it pretty clearly, and it's really not strong at all. So I started thinking about it, and I said, well, since fillet welds are hard, I'm just going to make them go away. I don't want to do them well, I just want to not do them. So how are we going to do it? If I can't work on the outside, I should work on the inside of the piece. So the way I solved the problem as a start was, this is a different sculpture, but it's the one I had a good picture of the process for. The lower box is a full rectangular prism, and the upper box has a cutout. So the lower box extends into the upper box. I then got some scrap metal, little bits and pieces that I welded to the outside of the lower box and the inside of the upper box as I left a face open. And so I did a whole bunch of work installing little bits and pieces in various directions, and I could get it to stick. I had to plan out a face that I could leave off that I could install later on so that I could do the work on the inside and then close it up. But this way I was actually able to get my pieces together, and it worked okay. So here's a bunch of sculptures that I built. First one is called 6 of 1. This is the initial one that I drew. Also, this one is called Retroflex and Noda Thistle. I got a lot of work done this way. I showed a bunch of sculptures. It was pretty great, but it still wasn't strong enough. I was still worried about killing children. Every time I installed one, I was real nervous, but it worked pretty well. Also, the assembly process, since I was sort of figuring it out on the fly where I was going to put the little pieces of scrap, it was just a mess. I was never sure if I was going to be able to do a good job of it. So I knew that I had to have a plan where it was really planned out. I knew that it was going to go the right way because I planned it to go the right way. So here's my design problem that I had to figure out. I wanted the sculptures to be strong and stiff, as strong as if they were welded up all around, except for I didn't want those welds to show and be there. I wanted the lines to be clean, which meant that even if I wasn't, even if I didn't have the welds on the outside, I wanted to have them, or I wouldn't be able to have them on the inside either. If I just welded up those seams on the inside, the outside would be destroyed from the heat damage anyway. I wanted there to not be any polishing required on the sculpture after the pieces are put together permanently, because if that was required, inevitably there'd be some arrangement of things that I came up with where I wouldn't be able to get the polishing tools in after the fact, and it just wouldn't look good. And finally, I wanted the joint alignment to be perfect. Since these things are sitting in these weird non-orthogonal configurations, it's really hard to get the alignment perfect, and it's really important to me that I do it right. Any technique that I used that involved joining the pieces with welding was likely to not be able to produce perfect joint alignment, because what would happen was I would get it right, I would do the welding, and everything, the heat distortion from the welding would cause stuff to move and bend the joint out of place. So I knew I had to figure out some technique that I could use to join the pieces that didn't get them hot. It turns out that there's a pretty good technique for joining things together without heat that is pretty well known. It's called bolts. So all I had to do was figure out how to bolt my things together, which is a little complicated anyway. But once I had that inspiration of like, put down the welder, I know it's the thing that I use for all of my sculpture processes, but let's use something else. It was easy from there. A side benefit of using bolts for this process is that after I join the pieces together, after I make that permanent configuration and get it all set, I actually can take it back apart, which lets me do all the finish cleanup on the pieces separately from one another, so I can get everything looking perfect, and then I just put it back together and have my sculpture. There's always going to be faces that I have to leave off and do welding on those at the end, but I can plan it out so I know that those are going to be sort of easy ones to work on. So here's how I did it. This is sort of analogous to what I showed before with the bits of scrap metal. This piece is the complete rectangular prism. This piece has the cutout, but now inside of the cutout I have another piece that I've carefully worked out in CAD, so it perfectly sits inside of the cutout hole and it perfectly sits flush on the other box, and I plan out bolt holes that are going to line up. So now that I have this all worked out, it's pretty easy to go and build it and have it come out right. The way the process goes, so you can see it, first step, I take the pieces that are going to be for this box and I weld nuts on the inside faces of them, and I have some tricks to get the bolts perfectly, or the nuts perfectly lined up inside of the, perfectly lined up with the holes. Then I take those three pieces and I weld them together into the box. So that's this here. You can come and look at afterwards if you like. So there's nuts on the inside. Then it's a little tough to see the difference here, but here I'm assembling this inside piece onto the closed piece. This ensures that the bolt holes on the inside piece and the closed piece are going to line up in reality and not just in CAD. So I take the three pieces, I bolt them to the box. When they're all bolted down nice and tight, then I put in these welds. Then I take all the bolts off and I take that piece off. Next step, I make the other piece. So now we have this big cutout hole that the first piece fits perfectly into. And the way I install the inside piece into the hole is with everything in place. So in the background here, this piece is the piece with the internal nuts. In the foreground, this piece is the piece that's going to have the inside piece welded to it. And here is the inside piece bolted to the open piece. So I'll put that together later. But the inside piece holds the open piece onto the closed piece in exactly the right configuration. Once I hold it in place, it's aligned just right, and then I can just go and put in some welds in this seam here. It doesn't take a ton. It takes 2 or 3 sizable tack welds on each line, and it's held as strong as you could ever hope for. So here they are sitting next to each other, so I've turned my CAD into reality, which is always a satisfying situation. I've taken all the bolts out, and now the pieces are sitting next to each other, so all I have to do now is all of my finish work. I can go weld up all of these seams, polish them, grind them, do everything, clean up the heat distortion on the outside so that you don't see those marks anymore, make everything look perfect, and then I put them together and close up the outside. So here's a few sculptures I've made with this technique. You can see that I'm able to do really far out cantilevered things, sculptures where it looks like pieces are kind of floating because they're just sitting on a joint that you can't even see. Big stuff. This piece is about 8 feet tall. So it's worked for me really well. It's pretty exciting getting it all worked out. So just quickly, my sort of design ahas in the process of the sculptures. Since I can't weld and grind every single fillet to make them all look nice, I wanted to just make them go away. Don't do fillets, do something else that'll work better. Since I can't work on the outside, well, don't try to do a nice job of work on the outside, just put the work on the inside. Maybe I have to figure out how I'm gonna do that, but I can figure that out. Since my ad hoc assembly process is a mess, I shouldn't have an ad hoc assembly process. I should have an assembly process that I plan out from the start. And finally, since welding is gonna mess up things in a way that I can't fix, don't use it. So in general, as I've solved design problems, as I've been working on sculpture, I've found over and over and over again that when I have a really hard problem that I can't solve, the answer is make the problem go away, take a step back in design and do something different. So for some final thoughts, my sculptures did all the things I was hoping for. They're complex, clean lines, and strong. This process also is adaptable to less orthogonal elements. I don't have to use these rectangular prisms. I could make octagons or crazy, funny poly surface things. They could all they have to do is overlap a bit, and I can use this technique to join them. Even if they're round, it would be sort of a big challenge, but I could still pretty much adapt it. It's also adaptable to different materials. Since the different elements aren't welded directly together, they don't have to be made of the same metal. So I got a commission for a piece that involved stainless steel and copper. And it was a bit of a trick figuring out how to weld copper and adapt it exactly right, but I was able to do it because this technique is pretty adaptable. Finally, this is a really labor-intensive process, and it's pretty exhausting, especially working in this piece I built this January, and it was very, very cold, and it was months of hard work in the cold Portland winter. But anyway, I was pretty excited that I got all this to work. So that's what I got to say today. If you're interested, I have the 2 demo pieces that I built, if you want to come and see. And one of my sculptures is upstairs on the 2nd floor, if you want to go check it out. Are there any questions? Yeah.
You talked a little bit about this, but can you talk more about getting the tolerances right for the holes and
yeah, so let's see. So maybe I will put this back on. The way I make sure everything fits exactly is that I make sure everything fits exactly in the CAD. So there's no approximations there. Oh, right. This is what I get for doing Google Slides.
Yeah, I guess that's what I mean by tolerance, like the difference between CAD
right.
and reality.
So one thing that was the thing that I had the most problem with tolerance actually was with the bolt holes. Other things, basically because I plan it out in the CAD using the metal thickness that it's going to be, things work how they're supposed to. And the metal, it comes out, like when I buy metal, it's exactly the thickness they tell me it's going to be. One difficult thing was, since these bolt holes are essential to the process, And they're not, right, I make those, I need them to come out just right. My first few iterations of this, I had a friend that had a plasma cutting table, and so I was doing this with plasma cutting. Plasma cutting stainless steel works, but it doesn't work super great. The edges were a little wobbly and there was dross. I had to do a fair bit of cleanup after to get the parts to be how they are in reality. And so it was particularly important for the bolt holes. I would have to go grind off both sides, drill them out, and re-grind. Anyway, it was a lot of work to get the bolt holes really clean, and that was, if I didn't do that work, so the trick that I do to align the nuts onto the holes is that I tighten the nuts down using a flathead screw on the other side, so the flathead screw centers the nut on the hole, and then I weld it down and I take the screw out. But if there's crap in the hole, the screw never comes out. And I had that happen to me like 1 out of every 3 or 4 holes before I got really rigorous about getting the holes clean and perfect. Now I use laser cutting, which actually laser cut steel is a pretty cost-effective process. These are 12 gauge, 105 thousandths steel, and for me, the budget to get a whole sculpture cut, which is about half of a sheet, is like $400 for the steel and the cutting. So it's only about $50 to $100 for cutting. It's totally reasonable process to do. I initially avoided it because I thought it was going to be prohibitively expensive. And laser cutting is amazing, and there's no dross, and I don't have to worry about the bolt holes at all. They just come out good. Yeah, so the way I deal with tolerances is I plan things out, taking everything into account, and mostly metal is what you expect it to be. I guess there are other places where, for instance, like if I put a weld here, if I put a weld in the area where the 2 pieces go together, I have to be really careful to grind it back so it's not going to get in the way. So I just try to make sure that any work that I do after I get the cutting back doesn't mess up the process. Anything else? Yep.
So could you, two-part question, do you have some resources that you use to hone your welding skills that you could share? And then also, did you play around at all with pulse TIG welding?
With pulse TIG welding. So let's see. Welding is a skill that is different from other sort of crafty skills that I've learned. Like if I were going to give somebody advice on how to learn woodworking, I'd say go build a dining table. But that's not the case for welding because it's really a skill that takes practice, like a lot of it. If you want to learn to weld and you have access to somewhere where you can go regularly, don't plan out a practice project, plan out a practice piece that you can do over and over and over and over again, and that you don't care about getting this one really nice so that you can go off and finish your table. You just want to like fill up lines with weld over and over and over again until you get good at it. Unfortunately, the best resource in Portland for that was ADX, but they stopped doing public classes. I was teaching TIG welding there until they stopped. But yeah, if you're interested in welding and you have a garage or someplace that you can do it yourself, go get a cheap welder from Harbor Freight and just practice over and over and over again. My welder has a pulse DC mode that goes up to 50 hertz. Frustratingly, if you want it to go faster than that, you have to pay them for a SD card that you plug in and it enables the higher frequencies. It's really criminal. So in my experience on stainless steel, I kind of like the pulsed. It does a better job of triggering my helmet to go dark, but it actually doesn't really matter too much. I found with welding copper that using the pulsed mode didn't work as well. I had better results melting copper without the pulse mode turned on. Copper was really challenging to weld because you have to preheat it. It's such an effective conductor of heat that you basically have to get the whole piece really hot in order to melt anything. So for whatever complex reason, copper, it didn't work very well. I've done a little bit of reading some literature on pulse DC, and the literature says it's useful at higher frequencies than I had access to, like 200, 250 hertz. I haven't really played with that. But for this kind of welding, it's pretty straightforward. Yep.
So when you put the bolts together and bolts and nuts, you put any Loctite or anything to keep it from galling or so they don't work loose?
So what I do is that, so like I said, there's a set of steps in my process where I put the piece together and take it apart and put it together again. And what I typically do is when I've put it together and it's the last time and I'm done, I go weld the heads of the nuts, or weld the heads of the bolts down to the piece, so they just never come out again. I've had mechanical engineer friends of mine tell me that if I tighten the bolts down really hard, they really should never come out again, but I just don't want to sweat it. So yeah, I weld them down. It's pretty easy. And it's always like a sort of a big moment for me because it's the one process in this whole thing that's really challenging to undo. You know, most of the things here, like I could take those pieces and cut them apart in 10 minutes and like do whatever I needed to do if I realized I made a mistake. But when I weld those heads down, it would be really, really hard to go in there with a grinder and cut those welds and get them back out. Yeah.
So when you tack weld the piece in,
Mm-hmm.
the corner, there's not any distortion that causes misalignment of the bolts?
There's a little bit of, so you can, if you want to come up and look, you can see, there's a bit of, well, I did an okay job. If I don't do a very good job of these welds, which is the thing that happens, I buckle the surface out here a bit. So like this one, I was a lot slower than this one, for instance. You can see it has a much bigger heat mark. And if I'm really slow, it makes these big bumps. Yeah, this one has a little bump. I go, after, you know, in my whole cleaning process, I'll polish these spots off, and in the places where I was slow, you can still see the bulges afterwards because it's just hard to get rid of them. And if I were to hit it with the grinder, I would never get those grinder scratches out. So I just leave the bulges because it's the sort of the best option. But yeah, it doesn't deform anything so that these holes aren't going to line up anymore. One problem I had actually was that I've had to get a little bit more careful welding the nuts down. So this actually can cause some heat deformation. Like when I do these 8 little welds to put the nuts in, this whole thing is going to bulge a little bit if I'm not careful about it. And then that can, since this is going inside of that bulge, can keep the line from being quite perfect. I've just had to get more careful about it. I'll like do one nut and then I'll go to this other piece and I'll do one here and I'll just switch off so the piece has a chance to cool so it doesn't build up too much heat. Anything else? Okay, thanks so much for coming. Appreciate it.